Okay, so now let's tackle the last part of the section, these difference quotients. So a difference quotient follows the basic formula of f of b minus f of a all over the quantity b minus a. Now some of you are going, wow, that's a basic formula. Well, it kind of is. It just is a little bit disguised. Like, it looks a lot more complicated than it really is. Because remember, when they're talking about f of whatever, that's really a y value. So this formula, you've got y's over x's, which means it's really the slope formula. So that's why they say it's basic. Basic because of what it represents, not how it's written. So a problem in calculus arises when we are asked to find the slope of the line through the points x, f of x, and x plus h, comma, f of x plus h. This would create a difference quotient of, so we're going to use this as our a, and this one is our b. So f of x plus h minus f of x all over the b, which is x plus h, minus the a, which is x. So that'll simplify down just a little bit in the denominator. So the denominator is just an h. So this right here, that is really a difference quotient, even though you don't have subtraction of the denominator anymore. You just simplified it. So to help get ready for calculus, because you're going to use this quite a bit once you get in there and early on, to help get ready for calculus, we're going to practice evaluating this difference quotient in particular, because it is a little abstract when you kind of look at it and it's just like, whoa, what's going on? Okay, so we're going to evaluate the difference quotient, and when I say the difference quotient, I'm always going to be talking about this guy right here. So this is what we're going to use. And we're going to use it with the following functions. So the first one we're going to use is just x squared. So now let's review a little bit. If I told you to evaluate with this function f of 4, what would you do? Well, you would take whatever's inside the parentheses and stick it in for x. Well, the same thing would be true if it was like that, right? You would just take the n and stick it in there. Well, if you look, we have f of x plus h. That's our first thing in that quotient. So let's just see what it looks like just on its own. How would you do that? Well, you would do it the same way as you did these two. You take whatever's in there and stick it in for x. So x plus h quantity squared. So when you do that difference quotient, when you're doing the whole thing, just kind of break it up into pieces. So your first piece is f of x plus h. So you're just trying to evaluate that guy on its own. So just take the x plus h, plug it into your given function, and see what you get. So in this case, we already did that. It's just x plus h quantity squared. And then minus, so minus f of x. Well, what is f of x? Well, that's just the original function. That's just x squared all over h. So your goal from here is to evaluate it and to eventually get this h in the denominator to cancel out. Once it cancels out, then you're pretty much done. And then calculus would take it from there and tell you what else to do with it. But for now, we're not doing that part. We're just going to evaluate this difference quotient and simplify it down as much as we can. So there are a couple of ways to do this. One of them is to factor the difference of squares, but most of the time people don't see that. So the other option is just to expand it out. I don't care which option you do as long as it's correct. Okay, so expand it. The x squareds cancel out. And if you notice, every term has an h in it. So cancel an h out from everything, and you end up with 2x plus h, and that's all we can do. Okay, let's go ahead and try it again with these next couple. So I changed the function, but I'm not changing the difference quotient I'm after. Still that guy right there. Okay, so again, f of x plus h, if that was the only thing you were asked to evaluate, you're going to take the x plus h and plug it in for all those x's. So do it. X plus h squared minus x plus h plus 4. So that's just f of x plus h. That's all we've done. So now you can go minus f of x. So now, because there's more than one term in f of x, I'm going to surround it with parentheses just so I don't forget that I'm subtracting off the entire function and not just the first term. That's where most of the mistakes usually happen. Not because you don't know what to do, it's just it's easy to forget. So if you're not getting these right, especially if this h is not canceling out, that's usually where it is. It's because you didn't distribute this across. So if you're not getting these right, I would check that. All right, so let's expand all of this out. So x squared plus 2xh plus h squared minus x minus h plus 4, and minus x squared plus x minus 4. It's like, oh my gosh, we got all this stuff happening in there. Well, that's okay. Sometimes it has to look worse before it can start to look better. So now the magical things start happening. So your x squareds cancel out, your x's cancel out, and the 4s cancel out. So 2xh plus h squared minus h all over h. And again, you have an h in everything, in every term, so cancel an h out. And there's your answer. Now I can ask you to find this difference quotient with pretty much any type of function that you've used in previous classes, including rational functions. So it doesn't matter what the function is, you're still going to start them the exact same way. So just do f of x plus h. Just pretend that was all you have. So this x would come out, x plus h would go in its place. So it's 1 over x plus h. Minus f of x, which is the original function, 1 over h. Now there are a few ways you can go with this, but we're trying to be the most efficient and the fastest way possible. So whenever you have a fraction with little fractions in here, you're going to try to clear out the little fractions. Well, to do that, the fastest way to do it is to multiply everything in here by their common denominator. So with this little fraction and this little fraction, your common denominator is x times x plus h. So you're going to multiply that to the top, and you're also going to multiply it to the denominator. And when you do this, it's going to clear out all the little fractions So that way you only have one numerator and one denominator, and it's a little nicer to work with. And I'll show you what I mean by this. You're going to take this green quantity and you're going to multiply it or distribute it in. So that would give you x times x plus h over x plus h minus x times x plus h all over x. Now, before I keep going, do you notice that you might be able to do something in the future? Yeah, you got some common things you can cancel out, and that was your goal. Okay, now in the denominator part, you just have h times x plus h. But up here, like we said before, you're going to cancel stuff out, so these fractions are getting cleared. So your x plus h canceled out from that, so you're left with x minus, now it's the x's that cancel, and you're left with this x plus h. Now keep the parentheses there. And down here, just leave it alone. Don't do anything to it. And if you're going, well, you can distribute that. It's like, sure you can, but you're trying to get this h to cancel, so if you distribute, you're just going to have to factor it back out to cancel it. But the numerator, you are going to have to expand that. So numerators, you typically expand. Denominators, you typically make sure they're factored. So your x's are gone on top. So it's just a negative h. And now you can cancel an h out. And you're left with a negative 1 all over x times x plus h. And if you want, you can distribute in the denominator, or you can leave it alone. Personally, I would leave it alone because then I'm done. Okay, so that is going to do it for section 2.1. So give the homework a shot and let me know if you have any questions.